Morale here, and we have been doing a lot the last couple of weeks looking at area. We first started by looking at areas of equilateral triangles, squares, regular hexagons. Then we moved up to regular octagons and 10-sided and 15-sided. So today we are going to look at finding the area of a 100-sided polygon. I know, crazy. So right here, as you can see on my screen, I've just Googled a 10-sided polygon, and a plethora of images will come up when I do that. And I can see, looking here, I can see how they've even broken it up into the 10 triangles. They're giving me one of the interior angles. They're giving me here one of the central angles. So I can see that this looks like definitely polygon, 10-sided. So let me go and look at a 20-sided. Okay, so now I have a 20-sided, and I'm noticing that besides being more sides, I'm noticing that the interior angle has gotten larger while the central angle has gotten smaller. Okay, let me move on. And I've also noticed that the shape is looking more circular, right? Because those sides have to be shorter. Now, what happens when I look at a 100-sided? Wow, looking at a 100-sided here, it pretty much looks like a circle, correct? Okay, so as the sides get larger in a regular polygon, it does start to look more circular, which is one reason why when thousands of years ago, when they were having to estimate the area of a circle, they would use, different sides and find the area of those triangles. So I could definitely estimate the area of a 100-sided polygon. If I had that the length was, say, 10, right, I could definitely estimate it by finding the area of the circle. But we're going to go ahead and find the area of a 100-sided polygon. All right, so 100-sided polygon. I'm not going to try to draw that. There's just physically no way for me to do that, okay? But I do know, and you know, that I can find the area. So my area, when I break up that polygon into its triangles, there's going to be 100 congruent triangles there. That means I'm going to do 100 times the base times height divided by 2. Take that one out. Okay, so that's what I'm going to do. And like I said, I'm not even going to attempt to draw that. I am just going to draw one of those triangles. It's not going to be drawn to scale because I already know that that central angle is going to be teeny weeny. Okay, so I'm going to go ahead and just sketch a triangle here, just like you would do on your paper. And I haven't said what I'm given. I'm going to say that I am given the base of this triangle. So the base of the triangle is going to be 10. Okay, so the base of this triangle is 10. All right, or I should say the length of the polygon, the side length would be 10 units. All right, so I now need to find that central angle. So my central angle is going to have to be 360 degrees divided by 100, which would be 3.6 degrees. So this angle right here is going to be 3.6 degrees. So that's a really, really tiny angle. So clearly my triangle is not drawn to scale. But I do know that the height is going to come down. It's going to be perpendicular. It's going to break up that base. So this is going to become 5. This is going to become 5. And again, I'm wanting to find this height. And it's also going to break that 3.6 degree angle into 2 equal parts, which is going to be 1.8 degrees. So this angle right here is 1 point, can I do a little point there? Let me go back, little point there, and that is degrees. All right, so now I have it set up. I already know my base. My base is 10. I need to find my height. So I'm going to use my good old friend trigonometry, and I'm noticing that if this is my angle, this is the side opposite, this would be the side adjacent. I don't have the hypotenuse, which means I'm going to have to use which of my trigs that don't have the hypotenuse? Well, that would have to be tangent, right? TOA, tangent, opposite over adjacent. So I'm going to go ahead and I'm going to use tangent. So I'm going to put tangent 1.8 degrees equals the side opposite, which was 5. So 5 over h. And I'm going to use my calculator and see what tan 1.8 degrees is. It is 0.03. That makes sense that it's really small because that's a very small angle. So I'm going to go ahead and I'm going to do 0.03 divided by 1 because I want to go ahead and make this into a proportion equals 5 over h. All right. I'm going to go ahead and write that cross product. So I'm going to end up with 0.03h equaling 5. Okay, to solve that, I'm going to have to divide both sides by 0.03. So I'm going to end up with h equaling 5 divided by 0.03. And that is 166.6 repeating, so 166, and I'll round that to 0.7, and that would be units. So that is my height. So my height is 166.7. I have the height. Now I can go back. I'm going to go over here, and I can find my area. So again, my area is going to be 100 times, oops, wait, I want 100. So it's 100 times my base, which was 10. Be careful that you don't use 5. It's this entire length. That's 10. So that's 10 times the 166.7. And that whole thing is going to be divided by 2. So I'm going to go ahead and use my calculator for that. So I am going to get 10 times 166.7. I'm going to times that by 100, getting a pretty big number, and then I'm going to divide that by 2. I am getting 83,350, and that would be my area, and that is in square units. All right, so you're noticing I'm getting a pretty big area with that. All right. All right. Watch this video, please. Watch it again if you need to. Hopefully you have noticed that we are using some of the same type of patterns over and over. Each time we're just finding the area of a triangle. Dependent upon how many is dependent upon the sides of that polygon. All right. I hope this video helped.